All right, we're on the air. Happy Friday, everyone. Today is Friday, February 16th, and this is episode 36 of Get Your Tech On, all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us today is John Downey, the prognosticator of cable. He's also CMTS Technical Leader of Cisco Systems. John, welcome, and thanks for being back with us. John, say hello.
I can't believe it takes a while. It's like I'm like a puppet, right?
It's that satellite connection, the satellite you're sitting on. There's a lot of delay.
I'm like a minuet. Just control my arms. Yeah, it's funny you said 36th episode. I'm like, my God, that's like 3 years worth, isn't it? Time is flying.
Yeah, it's one a month. We get them going. Also,
good to be back.
Also with us is Tal Laufer, a Ravenclaw, and also Director of Product Manager at ARRIS. Tal, thanks so much for being back with us this month.
Sure. Thanks, Brady. Thanks for having me. And I resent that. I'm a Gryffindor. Can't you see that?
Oh, indeed. So today we're going to be covering, well, let me get that. We're going to be covering a topic that is close to Tal's topic, or actually one that you picked out. It is cable access SDN orchestration, and so it's software-defined networking, SDN orchestration, and we're going to get into that topic in just a minute. I want to cover just a couple of things in the news. So Cable Labs just released the MAC-PHY standard for. So we've been talking a lot about R-PHY. This is the MAC-PHY standard that came out. But I want to see if there was any discussion. So we talked about that a little last week. Any thoughts on that? No, we can skip right over.
No, I can start, Brady. So yeah, it's exciting times, right? We have so many different options we can offer to the operators, and we have the ability to suggest the integrated CCAP, remote PHY, remote MAC and PHY, and going into PON later on. So all of them are part of the distributed access architecture trend that is growing in our industry. The remote MAC and PHY is another level of pushing down the functionality closer to the subscriber. It's got a lot of benefits, of course, so can't wait to see that materialize. The spec is still under works, so it's important to mention that there are ARRIS is actively a part of that as a Cisco, of course, and we're very copiously working on the details of that spec to make it available, to make it ready for deployment for the operators. I think that's going to be a very interesting offer and value proposition when it becomes ready. It's going to change some of the existing networks as we see them today.
So, also in the news. Go ahead, John.
I'd say from our side, we've pushed remote PHY to begin with for the simplicity, the keep it simple, stupid KISS principle. By keeping the PHY alone, very simplistic PHY that doesn't really change once the spec is done. You keep that out in the field, not much to do with it. It's very sturdy. The mean time between failures is a long time. You put the complexity more in a centralized location. I think it's funny that it'll tie in really good with what we're talking about today with orchestration and automation. If we do MAC-PHY, which we will also because we want to be technology agnostic and support the customer the best we can, there's more complexity will be in a node, which means if you need to update bug fixes, iOS, whatever, firmware, that's going to be highly automated. It's going to have to be, right? And we're going to end up with thousands of little CMTSs out in the field. Right. That the Mac has a lot of functionality that's software driven. So that's going to have updates and things like that. So I think this is a good segue.
Yep.
Great.
So the other thing Cable Labs is doing is they just pushed out the FDX Mac layer. So first they came out with the FDX PHY. Now they've come out with the FDX Mac. So that's continuing to push FDX further along the line. So again, we talked about that last month. Now we're just continuing to see FDX mature. So again, we'll see how FDX continues to roll out. So open that up if you guys want to
And,
talk any.
and that ties in just like what we said for the orchestration again. Because when we do FDX for this echo cancellation idea, that's going to have some quick automation to keep updating the equalizer, like equalizer coefficients, the echo cancellation, so that when one modem transmits, another modem doesn't get interference from that transmission. So your upstream downstream now is going to be full duplex, meaning I could transmit in the upstream at 500 megahertz. Another modem could be receiving at 500 megahertz. The same exact frequency, but hopefully, they're not interfering with each other, depending on their separation, their isolation, and this echo cancellation as well. But that information has to be updated. It's some type of automation has to do that updating. And how frequently does that update?
Yeah, I couldn't agree more, John. That's a great opportunity again for the automation and orchestration that we've been talking about. The FDX spec relies on certain clustering of cable modems to make sure that we transmit in different areas of the spectrum, such that modems will not interfere with each other. And to some extent, that's going to be done inside the the node or the inside the remote MEC and PHY node, but it will also be done in the SDN orchestrator of the network to some extent. So it will definitely tie into the topic that we have today. The FDX is is a great opportunity for adding more upstream bandwidth to our cable operators, right? So many of them are seeing the challenges today of dealing with the telco offering, going to high numbers on the upstream direction. So a lot of our customers are definitely looking into how they increase this upstream capacity, and FDX is a great segue. It's a great tool to be doing that. It's going to be very interesting to see how it materializes again, because it requires node plus zero type of architecture, right? That brings with it some challenges on the segmentation of the network, and how do you actually get the node closer to the subscriber to n+0 condition. So yeah, that's going to happen, but it's going to take a little bit longer, right? We see a lot of demos. There's a lot of talk about it, but until it really becomes a real deployable solution, it's going to be a little bit more until we get there.
Awesome. So the last topic is Cable Labs has been busy, but SpaceX has also been busy. Elon Musk, this comes from Science News, has just got permission from the U.S. communications regulation to start putting satellites in space, specifically for communication, broadband communication, for people who live in really rural areas like John Downey, who are stuck without good communications, and so this is I saw this, and of course I thought of John and his poor video and poor audio that we all have to deal with. And so I like this article that says the FCC chairman Ajit Pai proposed approval of an application by SpaceX to provide broadband services using satellites in the United States and worldwide. So nice thing that SpaceX is doing. Hopefully they put a satellite right over your house, John, very soon.
Are they? Did they say it's a LEO, the low Earth orbiting? Is that what it is, or didn't really say?
See if they say. I don't want to take up too much time looking at it, but no, I don't know. I don't know for sure, but I'll get to, I can send you a link to the article.
We heard that Google was doing that a few years back in rural areas and kind of developing countries, right, where it was really hard to get with actual infrastructure to those remote areas. They were doing that with balloons at some point, right, high orbiting balloons. So the satellite is kind of the next gen evolution of that one, I think.
Yep. Yeah. No, I do remember the balloons and also planes. They were going to do these slow flying glider planes that were going to supposedly provide broadband access.
Like drones.
Yeah, like drones.
Yeah, utilize drones. Sounds like a conspiracy to me.
That's moving too fast.
So Tao, you have lots of experience with cable access SDN orchestration, and I have to say this is something that I have not been on top of a lot. So I'm looking forward to this episode specifically to learn more about this. And I would like to start off with saying, what does this mean to the average cable operator?
Oh my God, this can mean a lot, right? So it can mean as little or as much as they would like it to mean. But I think that, if you look at analogies from other industries, there is already some SDN orchestration and more basically automation. Let's make it simple, right? Let's not talk about the SDN and the V kind of big acronyms. Let's just talk about how do you automate processes, right? And how do you actually orchestrate processes, which means when you want to manage two types of equipment, how do you make them work together? How do you make them talk to one another or have the same configuration so that they will not, overlap each other or interfere with each other? So think about it as in the kind of more simpler terms of how do we make the network management more efficient. And we've been seeing that happen already in the telco business. AT&T has been doing some steps in that direction. British Telecom has been kind of fostering an incubator for SDN type of development. There are a lot of different specs that are starting to come out for the last few years, like MANO and ONAP, and lots of acronyms I'm not going to get into. But the point is that the whole idea of the SDN orchestration is to make the cable access network simpler to manage and more automated and reduce the cost that it takes to actually operate that cable access network. So do things like automate procedures that currently require a technician to be doing that, and create more intelligence in the network management itself when it comes to potential use of artificial intelligence, machine learning protocols that will all be able to leverage, we will all be able to leverage those to make the access network more sophisticated, more intelligent, more self-healing, and more autonomous in its operation without the need to have a technician sitting there and clicking a mouse or typing CLI commands all the time. So it's all about, again, autonomous operation, automation, and orchestration.
Okay, so that kind of sounds like the 50,000-foot view of it, right?
Right.
So how does it start to trickle down from the 50,000-foot view actually into equipment? I know last month we talked about provisioning RFI devices and stuff like that. Does it actually get into that level of detail where we're provisioning equipment, or where does it start to actually impact, let's say, maybe a technician or someone that's operating in the head end, or like where do we actually start to feel this?
Yeah, so what you mentioned about the discussion from last month about remote PHY device orchestration or management, that's a very good example for the start of this whole process, right? So once we have the distributed access architecture going into the field, we suddenly have so many different active components sitting in the field out there and need to be managed. They need to be managed automatically, right? Because you don't want to go and physically change the configuration on each one of them. And remote PHY devices are going to be the first type of distributed access architecture devices that are going to be deployed out there. So what we talked about last month, I'm going to be kind of repeating that as a reminder that we were talking about an application and a manager that basically onboards those remote PHY devices when they're in the field, make them work out of the box, just like you have a modem that starts to work when you put it out of the box and connect that to the network. We want to make the remote PHY devices work out of the box, immediately being put into the network. And we want to allow the operator, the cable operator, to manage that in an efficient way, such that they will remember exactly where each node is located, what software version is on it, what configuration it has. It can monitor its state, it can change its parameters like power levels, etc., remotely and in an automated way. So this is kind of a very good example for the first step, right? Today we manage CMTSs or CCAPs using CLI, potentially. Sometimes we have SNMP MIBs as the management tool. When we go to distributed access architecture, we suddenly need something bigger than that, something that will be the overarching manager for all those smaller devices out there, and will basically be the first step into the SDN orchestration type of product.
Okay. Brady, let me give you an interesting example that I've heard where things could go a different direction for capacity planning. It's almost like load balancing. Instead of load balancing between downstreams and upstreams, we're load balancing between actual RPDs. Before, the cable MSOs and cable operators would say, all right, my node hit 85% utilization over a certain time frame, so I need to do a node split. I either do a physical node split or I add more frequencies and do load balancing. I call it, virtual splitting versus physical splitting. Now, if the RPDs are all off a digital network, you don't physically have to combine and separate RF connectors. You can have an automation process that looks at all the RPDs and say, all right, this RPD is underutilized because it's a rural area. It's only 5 customers. This RPD is overutilized because it's a couple college kids. Maybe I can combine those two to kind of share resources, and they're in the same service group. I see some RPDs, a clustering of RPDs are oversubscribed. I could either assign more license to it or more capacity somehow with physical frequencies turned on, or I could maybe separate that RPD from the other 5 it's combined with and just put it on its own service group. So I can reassign resources and do capacity planning on the fly. I think that's kind of going to be a cool, way to, quickly change capacity as we do today.
Yeah, I mean, it sounds a lot like the use case that you're talking about, John. It sounds like what is done a lot in IP networks with like load balancing, where right. you don't know how much traffic something's going to get at different times, but you know that it peaks out, so you put a load balancer in front, and when a lot of traffic hits it, that load balancer naturally just distributes the traffic evenly to the different devices behind it. So is that? I mean, that's kind of what I'm understanding you're describing.
Yeah, I mean, I think that's the power of going to the distributed access architecture with digital links now instead of analog optical links. Getting rid of all the analog. Now all the RPDs are off of digital links. It could be off of Metro Ethernet. So I mean, yeah, you could reassign resources on the fly. I thought another cool application. The CMTSs today are pretty resilient for DOCSIS 3.1 profile management. It's not crude, but it gets the job done. But if we want to take that a step further, where you're doing 4,000 subcarriers, maybe 8,000 subcarriers, DOCSIS 3.1 block to a cable modem, and you want to monitor the MER of all those subcarriers of every single modem every 30 seconds, or every 20 minutes, or every 30 minutes, you need some type of orchestration or application external to the CMTS to monitor that information and assign profiles that are different. The CMTS can manually, statically create 4 or 5 of them, and the cable modem can hold on to, what is it, NVRAM holds on to 5, I think. But what if I want to support 10 different 3.1 profiles? Because maybe you have a little bit of roll-off, maybe Tao has some problems at the low end of the frequency. Maybe I have a problem, a suck out right at 585 megahertz. Maybe someone else has LTE interference at 713 megahertz. So, I could have this orchestration just automatically give profiles left and right all over the place, and then change them if the frequency changes later on. You understand what I'm saying, right?
Yeah, just to add on that, the load balancing could also be done on between the MAC and the PHY, right? So, for example, if we have a certain MAC core that has got too many remote PHY devices hanging off of it, we can potentially use orchestration to load balance those RPDs to different MAC cores. Part of the strength of remote PHY architecture is that the MAC cores are centralized, potentially in data centers or centralized location, and you are reusing those resources all across your network, right? No matter how far they are. So the load balancing act in this kind of context could also be moving remote PHY nodes between MAC cores that are overloaded, as an example, and that's preventing congestion, preventing kind of limitations on the network that can come from a static configuration, so to speak. And another example, John, I really agree on the profile management side, and I think this is potentially something dear to Brady's heart. The PNM capabilities and the abilities we're getting from the DOCSIS 3.1 specs are ones that we could potentially leverage with additional level of orchestration. As you said, the profiles that can be used on the network can be really, can really change on the fly if we want them to. And if the network is seeing different types of SNRs, different type of noise in different areas of the spectrum and different times of day, and this can really change throughout the day because the temperature changes, for example, right? There are certain devices that produce more noise if it's hotter or if it's colder. So potentially changing those profiles on the fly, even throughout a day, will allow the operators to get more bandwidth out of their existing plant, right? Getting more bits per hertz based on the existing architecture and existing infrastructure, the fibers and the coaxes they have, dug deep. They can just get more bits out of that existing network, which is, it's priceless. It's an amazing development to be able to do that.
So if I'm a field tech, this orchestration is basically like dynamically doing node splits for me when on demand when I need it. If I'm a DOCSIS engineer, it's basically dynamically adding and deleting CMTSs on demand as I need it. It's managing my modulation profiles for OFDM as I need it dynamically. Of course, if I'm me and I'm a P&M guru, it's also helping me be much more intelligent about the way that I'm managing that.
Exactly.
So I'm starting to get pretty excited about this orchestration stuff.
So let me take that a step further, right? If we have the ability to move to virtualization as well, right? We talked about that last time, and I'm sure it's going to be discussed in the future as well. If you have virtualized MAC core, then your orchestration network can basically spin up new MAC cores on demand. If you see that you need more MAC processing capability out of your network, then your SDN controller can basically just spin up a new virtual machine, right, with the instance of that virtual MAC core, connect that to a new, to existing set of RPDs potentially as part of the load balancing mechanism, and boom, you've got a new CMTS basically, and you got a new type of access architecture on the fly and completely automated. Isn't that, magnificent as an option?
So it can spin it up. Okay. It's getting pretty interesting. Yeah. So yeah, you can just dynamically create it and add it in if you have the licensing, of course. But
obviously,
where does this?
Brady,
Yeah, go ahead, John. I'm sorry. We're just
my 2-second delay on my satellite. I have to start my sentence before you even say anything. You're excited about it, but what about the field tech that looks like he's losing his job? There's no RF in the head end. It's all digital. There's no node split. I would argue that might be part of the job that the techs hate, because the node split they have to do from 12 o'clock at night till 5 in the morning. So that might be a good thing. It goes away. So I think when we look at supporting a cable network, there's enough work to be done that even this automation stuff is just going to alleviate or relieve some pressure so they can get the other stuff done that they usually would do. The optics still need to be done out in the field. Ron Rannick would still argue to still sweep, a node plus 0. I would say that we could use full bandwidth capture in lieu of actual sweeping. But maybe there's still a case to use, frequency domain reflectometry to find suckouts and reflections. But we could still use P&M for that stuff as well. So it's definitely, there's going to be a lot of work that's still there for the field techs, the RF techs. The head end techs might transition from a typical head end RF guy to really an IP guy or a digital guy, optics guy. You still have optical levels that need to be maintained. It's not, this stuff isn't, this is not Skynet yet, this is not Cyberdyne networks.
No, and a lot of the functionality is going to be basically decision supporting systems, right? Not necessarily ones that will do and execute the change in the network for the operator, but just recommend what they should do, right? Potentially, we would create optimization systems that would say, okay, this node split should be considered for splitting, right? And not necessarily executing that immediately. And in the end, it's going to be a man there that will have to, or a woman, that will have to decide, when is a good time to actually be doing this this kind of activity, and they will have to kind of harmonize that with the rest of the things that that operator is planning on doing, right? So it's going to be a lot of, decision support systems.
does orchestration also get involved in configurations? A lot of the equipment now has the automated attenuators, automated equalizers. Does orchestration get involved in that? So, as far as like changing configuration of the equipment itself.
Yeah, I think so. I mean, I am pretty positive that's going to go in that direction. The change of configuration is something that should have been long automated, let's put it this way, right? I mean, the fact that we're still using CLI in 2018 these days, it's kind of ridiculous. A lot of the other industries that are parallel to ours have gone to the automation direction, and we must go there ourselves. Otherwise, we'll lose our market to some extent. The actual automation requires us to change configuration for CMTSs, for amplifiers, for nodes, on an on-the-fly basis. We need to be able to react fast to changing environment, to noises on the network, and to potential changes in the service that we have to do. Right. For example, a cable operator needs to be able to very quickly spin up a new VPN network for a new business customer. They need to automate that because the customer, the new business customer, will not wait for 2 weeks until they spin up their new VPN or MPLS network, right? They need to be automated so that the operators can offer a more flexible and a faster reaction to the market demands.
Sure.
So Brady, you saw our demo at the ST Expo with the iNode. The iNode got away from pluggable EQs, pads. They're all internal, all automated. I foresee that being, I set up my iNode according to your specs, your RF output levels, your tilt in the warehouse, and then I give it to the subcontractor, the contractor, the RF tech to take out in the field and install it. But it's pre-set up, and then maybe they use a QR reader or something to scan it in and tie it to the lat long, the GIS location. But it would be all automated pads and EQs. We had for many years very crude, and we still have it, AGC and ALC, automatic level control, based on a single pilot, which, that single pilot, if it goes down, you're screwed for all the other frequencies. So it's like, we need something that could monitor, the RF output of maybe every single RF channel, and then change everything to be exactly the levels you need. I would say that the upstream is going to be even more of a problem if we go 85 megahertz because of the temperature fluctuations. There's no AGC in the upstream. The only AGC we have in the upstream is the fiber or the cable modems in the CMTS negotiating their levels. So, 85 megahertz, you can have a big swing at 85 megahertz. Now we're talking 204 megahertz. Now we're talking FDX up to 500, 600 megahertz in the upstream. Coax is a killer, and temperature on coax is a killer. So if we limit our coax, we're much better. If we could control the temperature, that'd be great. But if we go down that route, we could talk about temperature change.
Yeah, so I guess that's where I was going with my question about does this orchestration have the ability to make those changes in the amplifiers? And normally we would say that would be a bad practice. Why would we, once we set up and sweep the plant, why would we ever change the pads or the equalizers? Well, one concept would be if we had something bad happen to the cable plant where we have a degraded cable and we have modems start to go offline. This is kind of like the concept of a pre-equalizer in a cable modem, where that pre-equalizer compensates for something that's bad happened to the coax, or maybe it's in a subscriber's home. The pre-equalizer in a cable modem is changing the way that cable modem is transmitting. It may cause the cable modem to transmit at a higher power, so it can compensate. The same thing might be happening in the amplifiers, where with the orchestration, we can see that suddenly all the cable modems have a drop in receive power in the downstream.
Right.
We don't know why on a certain leg, but maybe there's damage. A squirrel was chewing on the coax cable. So now we have the ability through orchestration to increase the transmit power on the amplifiers temporarily. Well, so we can get those modems back online and set-top boxes until we can go out and find and repair that damaged cable. So,
exactly.
That's something that's possible.
But what's interesting about that, Brady, is because if we're doing an RPD, remote PHY device, the RF is being generated right there at the node. we have control of individual RF channels, not like changing a pad across the spectrum or an EQ to tilt. We could control each individual RF output. So if we notice that maybe, and this could be hypothetical, like once we hit 50 or 70% of the modems all reporting the same RF channel band, maybe the other 30% aren't, but maybe that's enough for me to justify turning it up at the RPD. It might be hitting hot on the other 30%, but the 70% are now getting proper levels. You understand? Like maybe you have to come up with some type of solution.
Yeah, you're going to have some criteria, and this is where I think the the machine learning or the intelligence that Kyle mentioned that's in the orchestration would come into place and say, if this happens, then we can come in and make some adjustments to get our subscribers back online until we can get a tech out to find out where the problem is, fix the problem.
Yeah, exactly. That's where the integration of different data sets comes in, right? So if you have data points from the amplifiers, from the nodes, from the transceivers inside the head end, from the edge QAMs, from the CMTS, if you combine all those data points together, this is where the real synergy comes in. This is where you start really benefiting from all the data that you have collected, because you can cross those data points and know exactly what's wrong. So for example, if you see that a specific TV channel is showing some problems, you can really track that down up until the head end and see whether the problem is with the mixer, with the transmitter, with the actual amplifier, right? Is it a squirrel that chewed it up? And you basically can look at every point down the chain and see the power levels potentially for the signal that is carrying that channel, and potentially get into even higher level of accuracy on your troubleshooting and even self-healing system, right? You can automate that. Just imagine that you get some report from a few set-top boxes in the same neighborhood, and you know where they are, right? Because you know where everybody is located, and you see that everybody got a sudden drop in power because something happened to the actual cable. You can create an automatic reaction for the network, a self-healing network that will automatically just bump up the power, just automatically add a couple of dBs and see if that fixes the issue. Just imagine how great would that be. So that is kind of the idea of the self-healing system that is also coming with orchestration. And I have to tell everybody that it's not that far from reality, because we're seeing some, first of all, when we move to node plus zero architecture, there are less amplifiers down there, right? So less of those amplifiers to manage. But it's going to be a while until we reach node plus zero all over the world, obviously. And up until then, we see that there are products in the market that are actually offering amplifiers with cable modems inside them, right? Transponders inside the amplifiers, which basically make them a communicating device for every purpose, right? You can go and configure them, just like John mentioned, remotely. You can change the settings remotely, and you can, again, fix problems in your network through that.
Very cool. Very cool. So where does orchestration reside? Like, where does the intelligence for orchestration reside in the cable network?
So it resides in new products potentially that will be the managers of that network, right? The grandmaster orchestrator, or a specific purpose type of orchestrator that would be sitting inside the head end, a centralized, management network of the operator. And all probability it's going to be a virtualized product, right? We're going to the virtualization direction, so it's going to be some kind of an intelligent manager sitting on a Docker container, potentially a virtual machine, sitting in off-the-shelf type of server or hardware, potentially, that can host it. And we can also scale it, very fast if it's completely virtualized. You can spin up more instances of that manager if you have if it is completely virtualized. But some of those functions already exist in our CMTS and CCAPs today, if you think about it, right? Some of the load balancing mechanisms that we all implemented in our CCAPs and CMTSs are already partially SDN type of functionality, because we're load balancing physical network elements such as modems or nodes, etc. And we're changing the way they are configured, we're changing the way they are being set up. So, if we think about it in a more philosophical way, it's all over, right? It's already existing, and it's in all of the existing products. But the ones that we're talking about now are more specialized and even more intelligent, and will be sitting higher up in the hierarchy of the cable operator.
So, John, if so we have load balancing in the CMTS right now. Would you envision someday a lot of the functionalities that we would expect in a CMTS or CCAP to be just take load balancing, as Tal just mentioned? Would that functionality eventually move to orchestration and maybe some of the intelligence that we typically have in a CMTS that just be migrated into orchestration, and CMTS's CCAPs would become maybe less intelligent?
No, it's not if, it's when. I mean, that has to occur. I mean, it has to. I mean, I'm not afraid of losing my job. My
that's
job.
Good. I got news for you, man.
Best practices. So the unique situation I'm in is I'm kind of like a liaison, right? I go around all these different systems throughout the world and go back to our own engineers and say, hey, this is what we're seeing with Comcast and Charter and Net in Brazil and Rogers in Canada or whoever, and say, here's some default settings on the CMTS. This will get you by. You always keep it simple. You keep it the low hanging fruit. I use all these metaphors for no reason. They don't even apply, right? I just throw them out there. And so we have these defaults, but then when you get in real world situations, we're like, it'd be better to maybe change your parameters to be self-healing. But you always have pros and cons. You got to tell the customer, here's what we could do. Now here's the trade-off. There's a little bit more overhead on the CMTS. There might be a little bit more overhead on your downstream, so your capacity drops a little bit because you're doing more station maintenance or more monitoring, more information transmitting back and forth. But it'll give you maybe self-healing. It's kind of like you can buy insurance for anything, but how much insurance do you really want? So you have to have the best of both worlds. You got to balance it off, compromise. So if I do all these best practices over the years, maybe I don't have to do that next year when automation does it for me. It's going to monitor the health of the plant. Now I might have some best practices of what I would recommend as thresholds that you put into that automation, because the automation, you have to have some type of thresholds that you configure to say when I should change my capacity, when I should change my RF levels. We talk about quality of service, but really that's been changing, right? We could call it quality of experience, the QoE. I don't care what the capacity is saying on a fiber node, because I don't know if that 85% utilization is 85% on a 5-minute rolling window or an instantaneous 85 seconds that only occurred for 0.5 seconds. You understand what I'm saying? Like, is it really congested? When I used to turn on Power Boost,
you would freeze up.
I could have my Power Boost as I can, but no one's complaining. So there's a case where quality of experience was great, but it would indicate I need a node split, but that's not true. So I need to test quality of experience. Don't really worry about what capacity is, because everyone might be happy anyway. But then I might say, all right, with quality of experience, I'm seeing some congestion somehow. Upstream congestion is easy to track. Downstream congestion is a little bit more difficult. But you could monitor information, S&P, MIBs, and OIDs, and then say, all right, when I hit a certain threshold of queues that are backing up, add more capacity. I offered a DOCSIS 3.1 speed, and I'm more concerned about peak rates. And instead of trying to offer an aggregate pipe that's 2x of that peak rate, maybe if only one customer is asking for that peak rate, I can get away with 192 megahertz of OFDM block that'll give me 1 gig service, but I would never really want to offer that to 4 customers sharing that block. But it's only 1 customer, so I can afford to only turn on 1 block. But then when 3 more customers sign up, I have to now quickly turn into 2 blocks, so those 4 customers can share the 2 blocks and be better statistical multiplexing, better probability, less collisions and all that. So I mean, that's the case where automation would say, all right, when can you talk about spinning up Mac 5s and stuff like that. I'm spinning up more capacity by just telling the RPD to turn on more RF frequencies. RF frequencies, that's redundant. RF signals.
Hopefully Ron's not watching.
Gotta correct myself. Yeah, no kidding.
So
I don't actually think that the load balancing function itself will move when you talk about load balancing cable modems inside a service group. I don't think it's going to move, to the orchestrator as we talk about it right now, because it is kind of part of the function that is the CMTS or CCAP or VCCAP type of functionality. And it's important to also keep, those functions inside the right place where they can bring the value. But what I think is going to be orchestrated are the level of quality of service. For example, service classes and the actual tiers of service that can be orchestrated from the top, thus providing the input to some of that load balancing, right? So potentially, if we have a bunch of customers who want to change their SLAs, right? We want to be able to change the quality of service they're getting, or we're seeing that a bunch of customers are seeing bad quality of experience, right? We don't necessarily see the congestion in the network, but we know that the quality of experience at the end point, like the TV that they're watching on Netflix, is not good. Then we know that we need to fix something potentially in their service tiers. And we can go in and orchestrate different parameters inside the CCAPs and the cores that are in the network to optimize, the service and quality of experience for those customers. That's where the actual benefit is going to come from integrating that level of information from the top.
I agree. I kind of tiptoed around the question to begin with. But the load balance itself, 2.0 modems, single channel tuners, they got a load balance. I think orchestration, SDN, and all this allows us to optimize the plant so less load balancing is needed. And a case in point would be also today, and depending ARRIS or Cisco, what if a modem is an 8-channel capable modem and there's 24 downstream channels? So it has 3 groups of 8 to load balance between, DOCSIS 3.0 load balance. What if the modem moves to a higher set of 8 frequencies and that house has roll-off on the high end? SDN and orchestration could keep track of that modem's signature and say, you know what, I will allow you to load balance, but never to that last group of 8, because I know that house has problems at the high end frequency. I'll allow you to load balance between the 2 groups of 8 on the lower end, but exclude yourself from the last group of 8. Today, a lot of that is not smart. The CMTS might say, all right, you can move. Oh, but now you have a CM status message that said you have a problem, so I'm going to put you in partial mode. So now that modem went to 7-channel bonding instead of just staying 8-channel bonding on the lower frequencies.
Yeah, or it would even be it could get into the failure list because it tried to move it and it would just be a failure.
Correct.
Might have to fail 3 to 5 times before it actually gets excluded from load balance.
Yeah.
And then once it gets excluded from load balance, it might not load balance between the 2 other groups of 8.
It's stuck. It's stuck on its group, because I have seen that exact scenario happen.
So orchestration can keep track of all that and say, I know this house, MAC address Dead Beef Cafe, whatever the MAC address is. That's a joke, by the way. Dead Beef Cafe. So that MAC address, I know his signature for his house, and I could make his own group or load balance group just for him. So
yeah, that would actually be seemingly a much more intelligent way of handling it. So who is driving orchestration? Is this being done specifically by vendors? Is it a standard being done by cable labs? Who's making these specific decisions of, oh, we'll handle load balancing in orchestration, or we'll handle load balancing in the CMTS, or oh, we're going to start handling cable or node and amplifier transmission increases when modems go offline. Like, those are really, really complex and critical decisions for a network. So who's making these decisions?
So first of all, I do think that the driver is just emerging from the need of cable operators to simplify their network, right? To automate as many procedures as possible and to make it easier to use. They just need, help with managing their network. As I said earlier, the distributed access architecture devices out there are just becoming too many to efficiently manage without automation and orchestration tools. So in order to really make use of the new technologies that we're coming up with on the access side, it really must come with another set of tools on the orchestration and network management level to really be able to benefit from that new technology. So, customers, operators, all over the world are asking for additional tools to do things more intelligently. There are no CableLabs specs per se in terms of the orchestration of the network, right? When we talk about network orchestration, then it becomes a much, kind of access agnostic type of question. You need to manage a network, whether it's DSL, it's access, it's cable access, it's PON. You need to be able to manage a complete network, and for that there are some specs. There are, I mentioned earlier, the ONAP, the MANO, the ONOS type of products out there. So a lot of different specs that exist to try to define at least the protocols and the interfaces between the different machines in that domain. So it's starting to come up, and starting to arise as specs. But in our cable industry, it's still far from that, because every device is speaking another language, right? We all part of John and I are part of the vendors that are basically doing that, right? Creating boxes that speak their own proprietary language to some extent. Some of us, some of the boxes, speak the DOCSIS MIBs according to the CableLab spec, which is really good, and it's a good start. But there are still a lot of proprietary interfaces out there. So there's still not standardization, not a valid standardization out there that we can use to make orchestration work. So every orchestration solution that is being built by one of the CCAP vendors or by other companies needs to be able to talk to a series of different devices with their own proprietary interfaces, which brings in one of the bigger challenges of actually orchestrating the network, right? You need to be able to speak to 10 types of devices, each one of them speaking a different type of protocol or MIBs or CLI commands. So hence, one of the challenges for getting an efficient solution in that area.
Do either of you see this being something that MSOs will drive to be standardized, to become like a orchestration spec?
If I were an MSO, I would do that years ago, because I think there's a lot of value for standardizing the interfaces to different boxes, right? NetConf and Yang models have been discussed and were originally part of the CCAP spec, if you remember that, the CMAP, CCAP, Caesar, whatever name you call. Each one of them had a chapter that referred to this NetConf Yang type of model to talk to a CCAP. That never really happened, right? Us vendors didn't really implement that because it was not needed. It was not high in our priority list to do that. But eventually, if we really want to be able to orchestrate the network in a unified way, there was going to have to be some kind of standardization, or at least a common ground of, for all of us to be talking the similar language.
Yeah, I agree. You talk about who's driving this, Brady, to MSOs. It's an open market. Supply demand. The demand comes from the MSOs. The MSOs say, hey, we would like this. It ends up showing up in an RFQ. And then we all bid against each other for the business, who can support what, and then maybe some of it's proprietary. But it would be nice if there was real interoperability. The joke is that's a great thing about what say of them. there's so many standards, but they're not really standards. So I guess it's an oxymoron at that point.
Pick and choose what you want to support in the standard.
Yeah, no kidding. And I thought it was kind of funny. I think one of the MSOs went to CableLab and said, hey, can we standardize amplifier housings and node housings? I'm like, a little late to the game, isn't it? We've only had this stuff for 50 years.
I think more than that.
Yeah, and we're going to node plus 0. So, maybe they want to standardize the node itself, fit, form factor, and all that. I know the standard for power is there, meaning they're trying to push for less than 160 watts per fiber node. So it's trying to get a lot into a small area. That's the big thing about, the remote MAC-PHY. If we put the MAC in the node, what's going to happen with the power requirement? Yeah. That's going to be a concern, I think.
So where do you what is the glass? So I can't think of the analogy there. The crystal ball. Thanks, Sean. You are the man with the analogies. What does the crystal ball say the future
Give
is?
yourself one of those little magic 8-ball. Get one of those magic 8-balls.
I need one of those. So what's the future now? I mean, there's a lot of cool things you guys have talked about with orchestration. What does the future say? Like you guys said, can you kind of project what are even more cool things with orchestration? Can you elaborate on the roadmap a little?
Yeah, I think that we're going to start seeing that more and more, starting this year already, with different set of functions. There's not going to be, wham, bam, thank you, ma'am type of solution that, hey, I'm going to put it in and it's going to manage my entire network. No, that's not the way it's going to work, right? It's going to be a type of a growing solution, a type of evolution. We will add more functions that will orchestrate different types of pieces in the network, right? Different segments of functionality. So the example for management of RPDs, right, remote PHY devices out there is going to be a good start. We will add, profile management for DOCSIS 3.1. All of those are, certain pieces of the puzzle that will add more and more orchestration. So we gradually are going to see more automation and more orchestration introduced into the network, and becoming more and more intelligent. And as I said earlier, the more data points we have from the network, the more collection points we have, the better synergy it will be, and the better type of value that we will get from those types of orchestrators when as much as they can pull more points in the network. So I think it's going to be an evolution, not as much a revolution. So it's going to be incrementally growing in terms of the usages of the orchestration solutions until we get to a point where it's really more and more automated and almost, self-healing, self-managing type of system, which is kind of further into the future, right? It's more of an Elon Musk kind of vision, I would say.
Elon would be happy.
Yeah, I agree. I mean, you're not going to rip out an existing HFC plant, especially if you're a publicly traded company on Wall Street. It's just going to cost way too much money, and then your stocks are going to drop and blah, blah, blah. So you're going to almost cherry pick, and some people would argue, well, I can cherry pick GPON, EPON, and some people have, right? You cherry pick a customer that wants to do business from their home, and you do an EPON solution if you have the back office for it and everything else. Maybe you do DOCSIS over EPON, I don't know. But you can offer very fast DOCSIS 3.1 speeds and compete against GPON. And look at the price points. You already have an HFC plant. Maybe you only upgrade one leg of a node. Maybe you only upgrade one node to RPD. And that gives you the capability to do higher modulation for 3.1, higher speeds just for that section of your cable plant. And then you just keep upgrading as you go. So that would be, evolving your network, pay as you go, right? Pay to play. See, metaphors, just throwing them out there. Pay as you grow, whatever it is. So I see that, but talking about the crystal ball, the magic 8-ball, whatever, the Internet of Things. Internet of Things is like everything is connected in your home, and people have talked about this years ago about putting your car into the garage, the car automatically connects to your network. The car downloads the latest songs and emails into your car, maybe maps, updates to the car itself. Your dog gets updates. the dog updates might be, just the tags and stuff and who he's been around out in the, I don't know. But you get the idea. Is there's a lot more devices that are connected to the network. So we have to make sure the network is automated enough to provide capacity and IPv6 and everything else.
From a security standpoint, I can see huge opportunities there where you could start pushing all the latest security updates to every device that's connected to the DOCSIS network. That would be huge.
Exactly.
I mean, firmware updates to modems, all the things that we're struggling with now.
Yeah, you're talking about security of devices like attacks on your devices, cyber attacks, the security of your house, home security, home automation.
Especially when you bring up,
and that could be the killer app.
Yeah, I mean, bringing up IoT, but even just down to the cable modems, where if we could orchestrate that for operators to make sure that when ARRIS or when Cisco releases the next security update, that's quickly pushed out and ensured that it's also very well tested. That type of orchestration, and if it's not, if there's a problem when it's pushed out, that it's immediately rolled back. Those are the types of things that could be, I see, be very well orchestrated, because right now we know that there's there's many devices out there that have holes in them, and people are worried about pushing firmware updates out because we have issues. So
right. So imagine that you do that for cable modems today to some extent, and you're limited on that front. You would be able to do that for remote PHY devices, remote magnify devices, right? Download the software upgrade that will prevent the security hole that you may have, or run another level of validation on those cable modems to prevent this latest attack, right? The ability to configure things, download software versions to those devices is a very powerful thing we'll all benefit from.
Yes, absolutely. So any final thoughts on orchestration?
I think we used up our analogies, but just again to emphasize on the point, it's definitely not it's not a revolution. It's going to be an evolution. So operators and vendors are going to be having to pick and choose which automation functions and which orchestration functions will provide the most value in the short term, and apply them already this year, next year. And later on, grow on based on those automation functions that are already introduced into the network, all the infrastructure of those automation functions, and collect more information, make it more and more intelligent up to a point where it's a really intelligent network manager.
John, anything from your side?
You're talking about analogies and metaphors and all that. And you and I both worked at, Secor Electronics way back in the day. And there was an engineer one time that says, John, if we make everything idiot proof, you have more idiots that work on it. So my concern is when we make things all automated and then we forget what's really happening in the background, we lose sight of, the basics. And this is why Ron will have a job forever, teaching the basic RF stuff from soup to nuts, going through it all, and explaining what's really going on. Because if everything is automated and you don't understand that automation has the wrong parameters in it, you might not question it. We've had cases where people would do an FCC proof and say, oh, this node came out with a 60 dB CNR. It's perfect. It passes. I'm like, wait a minute. If it's too good to be true, then you should be questioning why it's 60 when a fiber node with a 10 dB optical link budget should only get like a 48 or a 50, according to the spec. So how is it getting a 60? Obviously, you did it wrong, but they don't question it, right? Because they got their good numbers. So we need people to understand how things still work and not just throw people at it once it gets automated. So we still need the expertise. We still need education. This is not going to be a blur for SCTE, but SCTE has their continuing credits and all their courses and all that. And most of that stuff is automated. It's online anyway, so people can stay up to date with what's going on with some of the technology and backtrack to the basics.
Yep. Good point. Everyone still needs to be shown where the power button is. So
don't mind the wizard behind the curtain.
That's right. So hey, if operators want to learn more or find out more information on orchestration, is it just they go to your company's website, to Cisco, to ARRIS's website? Is that the best place to go right now, or is there any public places that you can learn more about orchestration?
Yeah, it's a good question. I don't have a good recommendation on that one. There are a lot of, articles in the cable industry news about the different types of approaches to that. We do have some material on our website and ARRIS.com, some white papers, some presentations. But it is kind of in the early phases of this orchestration. So it's a lot of CTO type of talk and ideas for the greater good we're going to be able to provide with this network, but not as many products. So I can't really give you a data sheet just yet for this kind of product.
Okay.
Yeah, I would say, Brady, the best online one is Google. Just Google it.
Yeah. Google it. All right. Well, Tao and John, thank you so much. This was really, really fascinating, and I think a great topic. I'm going to look forward to see how this emerges. Our next episode next month is going to be all things spectrum analysis with Larry Wilcott from Comcast. So tune in next month. We do our very best to bring you some good technical content every month. If you like watching this episode, please click on the subscribe button or follow us on your favorite podcaster for our audio only episode. Again, thanks for tuning in. Tao, John, thanks for joining us. Really appreciate your subject matter expertise on the topic. And so everyone, have a great weekend. We'll see you later. Bye all.
It's a pleasure. Pleasure as usual.